variables, but now I've chosen some kind of a trigonometric field, and I'd like to write that down right now, okay? So let's go ahead and write down my field. I've got it written right here. So here's my field. I've got y squared. Hopefully I don't break the cable. I've got y squared plus cosine x cubed minus x squared y. Okay, that's going to be my x. That's going to be my x coordinate of my vector field. And what's my y coordinate? Here's my y coordinate. 2xy plus 1 over 1 plus e to the 2y. All right, ladies and gentlemen, that right there is our vector field. That's our vector field. Now, our goal, what is our goal? Our goal is to use Green's theorem to find the following expression. We have to evaluate the line integral over the curve C. This is our curve C. We have to evaluate the line integral over that curve of the following dot product, f dot dr. All right, student, everything okay? You need another paper? Here you go.
Okay.
Now, what this is essentially telling us is really quite simple, okay? When I talk about f dot dr, what am I really saying? I'm saying I want to find the work done by this vector field on some particle that is on that particular path C, okay? So go ahead and make sure you understand the conceptual part of the problem before you get into the mathematical part. Because if you don't understand the conceptual, you're not going to understand the mathematics, that's for sure. As is a motto in Bari Science Lab, memorization is a crime. And you'll be forced to memorize the mathematics if you don't understand the concepts. So make sure you understand the conceptual before you get to the math.
Memorization can only be decriminalized by understanding.
That's right.
Some words from me and the professor.
Some words from Professor Suborno Isaac Bari, author of The Love, recipient of the Global Child Prodigy Award by Nobel laureate Kailash Satyarthi. Go ahead and check that out. All right. Now, my book, of course, 55 Days in Darby, will be hitting the bookstore soon. So, selfless self-promotion. All right. Back to the topic, which is how do you evaluate this line integral? Well, that's what we're going to check out. Green's theorem tells us that this line integral over here is equal to the double integral. And of course, my double integrals always get messed up for some reason, but I always try to draw them nicely. So it's equal to the double integral over some region R, okay? And of course, that region R is going to be this region enclosed by my curve, okay? That right there is my region R. Make sure you see that, okay? So it's the double integral over my region R of what? Well, you can write it in many different ways. If you check out our street math lectures, you know you can write this as p dx plus q dy. But I'm going to go ahead and, sorry, that's for the line integral part. But I'm going to go ahead and write it down the traditional curl definition way. So I'm going to write partial q partial x minus minus partial p partial y. And all of this, of course, is going to be multiplied by partial a tiny differential piece of our surface A. Okay? Now, that's really the formula. That's Green's theorem, and that's what we're going to be using right now. So let's go ahead and use it, right? So, I have to first and foremost find partial q partial x and partial p partial y. So let's go ahead and do that. Maybe I have to lower my screen for the people who are watching live, but it seems like we're good. Okay, so I'm going to find it over here. Okay, so partial q partial x is going to be equal to partial x of what? Well, what's our q? Our q is 2xy plus what? Plus 1 over 1 plus e to the 2y. And that's what we're taking the partial derivative of. Okay? Now this should be pretty straightforward, pretty simple, hopefully. You know, you take the partial derivative of 2xy in respect to x, you're going to get what? Well, treat the x as a constant, you pull it out, you're left with 2y. So this is going to equal 2y Now, of course, this is just a constant because it's only in terms of y. So this partial derivative is just going to equal 2y. So it's really not as nasty as it would have been without doing 0. Okay, so I'm just going to go ahead and erase my intermediate work and just write 2y. Now, what about our partial p, partial p, partial y? How do we evaluate that? Well, that one's also pretty simple. Partial p, partial y is going to equal what? Well, we're taking the derivative, the partial derivative of this x component in respect to what? In respect to y. So this is going to become 2y. That's the constant, so it goes to 0. That over there is just going to go to what? Well, you pull out the y, you're left with just minus x squared. And that's it. We have partial q, partial x, and we have partial p, partial y. So we're ready to go ahead and start our actual double integral. Now before I do that, I want to go ahead and address any questions from the audience. No? Yes, sure, student. Another page, another page. Thank you, Professor. Now, while our professor is steadily and gratefully taking notes, why don't we complete this double integral here? Hopefully we can address that minor problem as well for our not live viewers. Okay. Now, 5 commandments. Name them all. Like, share, subscribe, donate, and of course, comment down below. Those are the 5 commandments of Bari Science Lab. Make sure you follow them. All right, folks. All right, all right. We're ready to evaluate our double integral. So we're gonna have what? Well, instead of partial q, partial x minus partial p, partial y, I'll be left with 2y minus x squared, and that will just simplify down to x squared. So that's pretty simple, pretty neat. Okay, so that doesn't look too bad at all. So now I can just go ahead and come over here and simplify all of this. Okay, so first and foremost, I need the bounds. Okay, so let's see. Of x squared, and instead of partial a, I have to think, is it easier to integrate by x first or by y? Well, check it out, check it out. As you can see, first of all, let's try to establish the bounds here. This bound right here is y equals 0. That's easy enough. What about this one? Well, this is going to be y is equal to 3 minus x, and likewise, you can imagine this one is going to be 3 plus x. Now, we see that it's easier to integrate by y in this way, or rather by x, really. It depends on what you're thinking. Yeah, it's easier to integrate by x first this way. So we can do partial x, and so our bounds are going to be from x equals 0. Professor, everything all right? Why do I hear that sound? Please, Professor, we're live, and we don't like much distractions. So instead of x equals 0, I'm going to have x equals negative 3. And that's going to tend all the way to x equals 3. What about partial y? Well, partial y, we're going to be left with what? Partial y is going to go from 3 plus x, or rather x plus 3, to x minus 3, or rather 3 minus x. All right, ladies and gentlemen, ladies and gentlemen. All right, so I'm going to have 3 plus x. Y is equal to 3 plus x, to y is equal to 3 minus x. Alright? Hopefully everyone can read what I've just written. If not, I'm going to just go ahead and erase this. Make sure that everything is legible. From y is equal to 3 plus x to
You mean
y.
intelligible, not legible, right?
I mean legible, Professor. Would you concentrate on your notes? And finally, from x equals 0 to x equals 3. And we're ready to go ahead and integrate this, folks. Bless you, Professor. Now, what is this going to integrate to? Well, if I can just write this a bit more packed, a bit more concisely, I think I can go ahead and simplify it. First and foremost, x squared is going to devolve. It's going to devolve into what? Well, the definite integral tends from 3 plus x to 3 minus x. We're going to have x cubed over 3 tending from what? Negative 3. Again, I put 0 for some reason. From negative 3 to 3. Professor, is everything A-okay with what we're doing?
Just trying to do something.
I don't think that's relevant, Professor.
No, I'm doing something that's relevant.
Alright, no need for arguments on live camera. Alright. And that is, of course, going to be followed by partial y. Alright, make sure you're aware that everyone can see what we're doing. Alright, folks, ladies and gentlemen, who's ready to continue? Give me a raise of hands. One of our students just left, but
Yay.
we are proud. Okay, so this can of course be simplified to what? Well, this is really quite an easy integral, right? We're going to be left with x cubed over 3 tending from negative 3 to 3 on the outside. But then we're going to have what? This integral on the outside, but that's going to be followed by y tending from 3 plus x to 3 minus x. Ladies.
Subscribe to Bari Science Lab to fall in love with math and science, especially programming.